Okay, quick explanation of the two types of limiting factors. 1, density dependent. 2, density independent. Let's break it down in very easy to understand components and define everything we need to so that I can give you an example. So density dependent, if we're just looking at the word dependent, that means determined or defined by something. Independent means not determined or defined by something. So when we add the word density, it means it's determined or defined by density. And density independent, not determined or defined by density. Cool. Then we're looking at density dependent and independent limiting factors. Just as a reminder, a limiting factor is anything that limits the growth of a population or species. So a density dependent limiting factor is something that limits the growth of a species, and it is determined by or defined by the density of that species. So let's go down here. Just looking at the definition of density, it means how many or how close to each other they are. How many of something in a certain area and how close they are. So when we say density dependent, we're going to say that it's more effective at limiting the population when there are more of them or they are closer together. That's it. So let's look at an example of the density dependent limiting factor. So here's an example of density dependent, something that is more effective at limiting the population when there are more of them or they are closer together. This is some deer, because it's easier to do the deer. I already have that image. There are only, say, 6 of them. So adults and children, there are only 6 of them altogether. Let's think of the resources they have that might limit their population. We're looking at stuff like some plants. That's what they eat. So food, water. Right now, there's plenty enough for all of them. There's enough water for 6 deer. There's plenty of food for 6 deer. Now let's look at whether or not there would be enough food and enough water for all of them if there are many more of them. Let's increase that population real quick. So now there are more of them. There are a whole bunch more deer, and it will start to run out of food. Now they will eventually run out of food because the grass won't be able to grow fast enough, or what they eat won't be able to grow back fast enough after they've eaten all of it. This is one of the reasons why we have hunting season, like deer hunting season, to control the population so that they don't eat everything around them and so they don't have to starve to death, which is a pretty terrible way to die. So to bring balance to the population, we have hunting seasons, and this is too many deer for all of this food. Let's add some more. But the really big idea here is that when there are more of them, it's going to prevent more of them from surviving faster, meaning more of them will die faster than if there are more of them than if there are fewer of them. If there are, say, just a few of these taken out, they will still be limited by the amount of food, but it's not going to limit them as quickly if there are less of them. And when there are more of them, they're going to run out of food faster, and it's going to limit their population. It's going to kill them much faster when there are more of them. Same thing with water. If there are more deer, they're going to run out of water faster than they would if there were very few of them. So food and water are density dependent limiting factors, because if there are more of them, it prevents them from reaching a higher carrying capacity, and it limits their population faster, not just more, but faster when there are more of them than if there are not more of them. So let's put some examples here for density dependent: food, water, some other things that we can say would limit the population faster if there are more of them. I would say predators. Let's visualize that real quick. So I took away some deer, and I'm adding this wolf. This is the best image I could find of it. We're going to make him smaller and put him in here. And is this wolf more likely to find their prey, which is the deer, when there are few of them, like you see here, or when there are a lot of them? So there are many more deer. Is this wolf more likely to find their prey? Like that? Or are they more likely to find their prey when there are fewer of them? Think about that. That's really what we're talking about when we talk about density dependent. It will be more effective, meaning they can limit the population faster if there are more of them, or they are closer together. If you only had 5, but they are all right next to each other, the wolf would still have an easier time getting to them. Right? Especially if there are more wolves. Oops. So when there are more of the deer, the wolves, the predators, can kill them faster and easier, so it will limit the population of deer faster if there are more of the deer and they are closer together. That's why predators and predation are considered a density-dependent limiting factor. They limit the population more when there are more of them around, more of the prey to be around, because they're easier to find and they're able to be killed much faster. So that's what we mean. Let's look at density independent now. So looking at density independent, it is not determined by density, so how effective it is or how many or how quickly it can kill a population is not determined by how many there are or how close together they are. So let's look at an example. Let's do weather. So, for example, if there's a really big, say, winter storm that came by, let's look at what would happen. Let's say that this is a giant storm and it rolls in over the population of deer. Here's the difference between a density-dependent limiting factor and a density-independent limiting factor. You can say that more of them will die if there are more of them, but you would say the same about anything at all. The biggest difference is that the winter storm is not going to kill any of these deer faster if there are more of them, meaning that it is not as effective or is not more effective when there are more of them. It's the same no matter what. If the weather comes in and there are only 6 of them, it might kill all 6 of them if it comes by, but that's just 100%. That kills all of them. Now let's see what would happen if there are more of them. Okay, so we've added more of those deer. Winter storm comes in, still kills all of them. It doesn't kill them faster, though. It kills them the same no matter what. If you're in the middle of the storm, you're in bad trouble, right? That's it. The difference is that when you have more deer, then you're going to have the predators kill them faster when there are more of them. When you have more deer, the food will run out faster when there are more of them. When you have more deer, the water will run out faster if there are more of them. If you have a storm come in, it kills them all at the same rate, no matter what. If this is a hurricane, kills them if you're in the path. It doesn't make the weather more destructive or more deadly if there are more of them. It's the same deadliness no matter what. If there are 2 of them there, it kills 2 of them. If there are 20 of them, it kills 20 of them. Here, though, if there's more deer, you will run out of food faster. If you have more deer, you'll run out of water faster. If you have more deer, the predators will kill them faster. But not things like weather. What's another one? Let's think of another independent factor. Some other things might be like earthquakes. Yeah, that can definitely limit the population, and it doesn't make any difference how many there are. Earthquakes can affect everyone. Volcanoes, it's going to affect everyone no matter how many there are. If there are 20 there, they'll hurt all 20. If there are 10, they'll hurt all 10, no matter what. What about the abiotic factors? Because I've heard someone say that density-independent limiting factors are things that have to do with the Earth, but that's not the definition. But you're right that it is usually things that are abiotic, like temperature and weather and things like that. But that's just not the definition. Keep that in mind. Usually abiotic factors, things that are not alive, are affecting density-independent limiting factors, whereas things that are density-dependent are usually biotic, meaning they are usually living things, like diseases. We can put that in there as well. Yeah, because if there are more of them, the disease will spread faster and kill them faster. That's the difference. So just keep that in mind. Density dependent hurts the population or limits them faster. It's more effective if there are more of them. And density independent factors, they were just going to affect the whole population no matter what. If they're in the way, they're in the way. Will not hurt them or limit them faster or more just because there are more of them. So keep that in mind. That's the difference between density independent and density dependent limiting factors. And these limiting factors influence carrying capacity. Limiting factors determine carrying capacity. So let's talk about that next.